Hi, I'm an old guy and I do maths, and the task ahead of us today is to factorize this. 64y cubed minus 48y squared plus 12y minus 1. And it looks kind of daunting. One could be forgiven for asking where you start. And where you start is by recognizing the form of this, and the giveaway is here and here, although this is not quite so obvious. But this whole expression can be broken down to this: 4y to the power of 3. 64 is 4 to the power of 3. Over here, as I said, this is not so obvious because it's 1, but if it were something like 8 or 27 or something like that, it would be more obvious that it's a cube. But 1 cubed, it is. And if we get as far as here, then it becomes possible to see that there is a pattern in here. And the pattern is that essentially this thing is the product of a binomial expansion. Now those of you who've looked at binomial expansions or have seen my videos on them will begin to recognize what's going on here. So powers are dropping, powers are increasing, and if we put this in an algebraic form, what we have is this: a cubed, which is this, minus 3a squared b. Now b in this case would be 1, so that's why it's just really minus 3a squared, plus 3ab squared, 3 times a times b squared, there's b, and finally minus b cubed. Now the pattern of coefficients 1, 3, 3, 1 we get from Pascal's triangle. So again, it's just having all of this information in the back of your head when it comes to looking at your original problem. And if you're a student at school or at university, somewhere buried in your textbooks will be this thing, which is a binomial expansion of the difference. Well, it's not really the difference, it's the difference between a and b cubed, we'll put it that way, but it's a binomial expansion of this: a cubed minus 3a squared b plus 3ab squared minus b cubed. It's worth noting this, it's worth having notes on this. And so if we get to this point, if we get to the point where we've started up here and what we've recognized is that we're dealing with something like this, all we have to do is figure out what a and b is, if it fits the pattern. Now a is going to be the cube root of this whole expression, which is 4y. So in this case, if I move the page down a little bit, you'll see that a I've noted as being 4y, and b, the cube root of this, is 1. And so in an instant, so somebody who knows this, who's used to working with this, in an instant can look at this expression here and go, that may well be a binomial expansion of a minus b cubed, and they can figure out what a is from the third root of that, and b is from the third root of that, and they note the negatives, and so this is a minus b all cubed rather than a plus b all cubed, which may well be the subject of another bit of factorising, and you can actually go straight from here to here. And if you really are a glutton for punishment, to check your work, you can then expand this, which of course is simply a matter of putting it all back into this form. So if you identify a as 4y, you can go a cubed minus 3 times a squared times b plus 3 times a times b squared minus a cubed. And what you'll get is what you started with. I hope this is helpful. It certainly should save a lot of grief and effort. And as I say, these particular patterns are really, really worth knowing. It's a good idea to get your head around binomial expansions. Thanks for watching. See you later.